My name is Shyam Kathinathan and today I am presenting my DA1 assignment on NAND2TETRIS, focusing on hardware projects 1 to 6. This course helps us understand how a computer is built internally, starting from the basic logic gates and gradually moving towards a complete computer system. In this presentation, I will explain what I learned from each project and also describe my plan for DA2 and DA3. This project is important because it gives practical knowledge about how hardware and software are connected. NAND2TETRIS is a project-based learning course developed to teach computer systems from the ground up. Instead of directly studying advanced processors, we start with the simplest unit, which is the NAND gate. Using only this gate, we build logic circuits, memory units, processors, and finally software tools. This method helps us understand how complex systems are actually made of simple components. By completing these projects, we gain confidence in understanding real computer architecture. In project 1, we focus on the Boolean logic. Here, we build basic logic gates such as NOT, AND, OR, XOR, MUX, and BMUX using only NAND gates. These gates are the building blocks of all digital systems. For example, inside a processor, millions of these gates work together to perform this operation. If these gates are not designed correctly, the entire system will fail. Therefore, this project forms the foundation for all other projects. Project 2 is about Boolean arithmetic. Using the gates from Project 1, we design arithmetic circuits such as half adders and full adders. We also create 16-bit adders and incrementers. Finally, we build the arithmetic logic, also known as the ALU. The ALU performs all calculations inside the CPU, such as addition, subtraction, and comparisons. Without without a complete proper ALU, programs cannot perform meaningful operations. Project 3 focuses on sequential logic and memory. Here, we design registers and RAM modules. Unlike combinational circuits, memory circuits can store previous values. For example, when we open an application, data is stored temporarily in RAM. This allows the CPU to access information quickly. Without memory, computers cannot run programs efficiently. In Project 4, we learn about machine language. We write programs in hack assembly language. This helps us understand how high-level programs are converted into instructions that the CPU can execute. We also learn about instruction formats and addressing. This project improves our understanding of how software interacts with hardware. Project 5 deals with computer architecture. In this project, we integrate the ALU, CPU, RAM, and ROM. We combine all previous components into a complete hack computer. This system can execute real programs. This is similar to how real computers are built by integrating different hardware units. It gives a clear picture of how hardware works as a complete system. Project 6 is about building an assembler. The assembler converts an assembly language into machine code. Machine code is the only language that the computer understands. The assembler also handles symbols and logic. This project connects human readable programs and hardware. In this slide, I have shown a demonstration using the hardware simulator. I loaded the built-in AND gate and its test script. After running the test, the output was verified successfully. The simulator helps us test our designs without using physical hardware. It saves time and reduces error during development. For DA2, I will focus on projects 1 to 3. I will implement logic gates, ALU, and memory modules. I will test each component using the hardware simulator. I will record the execution process and submit it as PDF. This will gain hands-on experience. This will help me gain hands-on experience. For DA3, I will work on projects 4 to 6. This includes writing assembly programs, building the complete computer, and implementing the assembler. I will use CPU emulator and assembler tools. This stage will help me understand full system execution. This slide shows the timeline for the assignments. A1 is scheduled for 10th February, A2 is scheduled for 10th of March, and A3 is scheduled for 10th of April. I will complete each step before the deadline. Conclusion: the NAND2TETRIS project helped me understand computer systems. I learned how logic gates form the foundation of computers. I also understood the importance of memory processors and software tools. This project improved my practical and analytical skills. Thank you for giving me this opportunity.